Hey, what's up, guys? Today I want to teach you guys about asymmetric and symmetric key pairs. So what are they used for? So basically, if you want to encrypt data in flight, you will probably use these two type of encryption method. And before I start, what is encryption? Encryption is scrambling data so that way nobody else can read what the original data was unless they have a key to decrypt it. And so, for example, let's just take data, and then you would encrypt it. So encrypt, and this will be encrypted data. Now, once you've encrypt your data, nobody can tell what the original data is unless they have a key to decrypt it. So that's the basics of encryption. And a lot of people confuse encryption with encoding. They're actually two different things. There's a way, once you find it, there's a way to decode the data once you find out about the rules of it. But the thing about encryption is there's no way you can reverse that data into its decrypted form unless you have a key for it. So just remember this. Encoding, there's a way to decode the data even if you don't have the key for it. And encryption, there's no way of getting the original data unless you have the key for it. Okay, and let's get started with symmetric encryption first. So in symmetric encryption, let me make this a little bigger. Okay, symmetric encryption is when you only have one single key for both the encryption and decryption. So let's just say symmetric encryption equals X, and you have a data over here, data, and you have two different persons. Let's say the classic Alice and Bob. Alice, and let's put Bob over here. So Alice wants to send data to Bob, but there's someone snooping in over here. Let's just call him Jake. So how will Alice send data to Bob even though Jake is listening over here with something like Wireshark? Alice will use encryption, and in this case, Alice will use symmetric encryption, where both Alice and Bob have a key, and they have the same key. So both Alice and Bob has the symmetric encryption key X, and they're the same. They're the same key. So what Alice will do is he will encrypt data, and send it to Bob. Even though Jack is listening over here, he doesn't know what this data is because Alice encrypted it. Encrypted data. And so once Bob gets this encrypted data, Bob's going to use his key X to decrypt it. So Alice and Bob successfully transmitted this data, even though Jack is over here snooping on it. And Jack, even though he got, maybe he used Wireshark or something, and he got this data, he snooped this data when it was being when it was in flight, which means when it was in the process of transferring from Alice to Bob. Even though Job might have gotten this data, it was in its encrypted form because Alice encrypted it before she sent it. And in symmetric encryption, you will use the same key for encryption and decryption. So Alice encrypted the data with X, and Bob decrypted it with the key X, and vice versa. Bob can also encrypt the data with X, and Alice will then decrypt the data with X. So one analogy that you guys can think for this is the door to your house. Both you, your mom, and your dad have the same key to go inside the house. So that would be symmetric encryption. You would use the same key to lock the house, and you will also use the same key to open the house. So symmetric encryption. But there's one thing about symmetric encryption. One small problem is, how do you get Alice and Bob to have the same key? How do you make sure Alice and Bob have the same key when there's someone like Jack stooping in first? How do you make sure Alice have? How did you know Alice have the same key as Jack? How did they come into the conclusion that they will use this key X? Because if Bob wanted to tell Alice that, hey Alice, let's use the symmetric key X, Bob will have to send that information to Alice. But the problem is, how will he encrypt that data? What if somebody's listening in on Bob telling Alice to use the symmetric key X? Wouldn't that person just use the symmetric key X as well and use it to decrypt whatever they're transmitting after that? So that problem can be solved by using asymmetric key pair. An asymmetric key pair is often used in conjunction with symmetric key pairs, or sometimes just by itself. There's also many other use cases. So you can use asymmetric key pair to send a symmetric key pair. And so basically how it works is, we also have Alice here, and we also have Bob here. And with asymmetric key pairs, there's two different keys. One public key and one private key. And you can think of the private key as your personal key, and the public key as a key that everybody else can see. So X private equals Y. And let's do private key equals Z, and private key equals, I don't know, O. Okay. Oops. Public. Okay. So in the same scenario, Alice will want to send Bob data with Jack in the middle, stooping on it, the connection. Jack, and then in this case, Alice will not encrypt the data with her own key. Instead, Alice will encrypt the data with Bob's public key, and the private key. It is what it says. It's a private key. Nobody except for the owner should have this private key. It's like the key to your house. You don't want to lose it. Only you should have it. Your phone, only you should have it. Nobody else should have it. Or a better analogy would be your ID. You don't want anybody else to have your ID, because if they do, they can impersonate you. That's your personal information. You don't want anybody else to have. But your public key, that's fine. That's for you can just put it out in the wild. Anybody else can see. Okay, so Alice this time will encrypt the data with Bob's public key and send it to Bob, and the encrypted data Bob will use his private key to decrypt it. So in this scenario, Alice sent the data, encrypted it with Bob's public key that anybody else can see. Anybody else can see. But even though they can see this public key, they can't decrypt the data because the public key and private key, they're linked. Only the private key can decrypt what the public key encrypted. Okay? And this is actually using mathematics. They use prime numbers. They use like really big prime numbers. I won't go too deep into details, but these two numbers, they're mathematically linked, and they're both derived of like a really, really big prime numbers. You do some more like multiplications, divisions with those the prime numbers, but I won't go too deep into that. But basically, you would encrypt somebody's, if you want to, in asymmetric encryption, to send data to somebody else, they have a public key. And since they have their public key, everybody else can see it. They will encrypt the data with that person's public key, and that person will decrypt it with their private key. And so, in using asymmetric encryption, we can use this to send data about our symmetric encryption key pairs. So what do I mean? So since Alice and Bob, they both have their public and private key, they can use this method to send over a symmetric key. And you might think, why would we send that? Why don't we just use this? That's because in this case, they use two different keys for encrypting and decrypting, and that sometimes can lead to performance being degraded. It will lead to like less performance. It might overheat your systems and stuff. Because doing these encryption and decryption, they use a lot of computing power. But symmetric key pair, on the other hand, will use way less computing power than using a private and public key pair. So in this case, Bob would encrypt the symmetric key with Alice's public key. And Alice will decrypt the symmetric key that was sent by Bob, that was encrypted with her public key by using her private key. And once Alice got the symmetric key, Alice and Bob will then start communicating communicating with each other using the symmetric key now. And that's actually how HTTPS works. That's how your data is encrypted when you go to Google, when you go to Facebook, when you go to any website, when you use the internet. That's the process of how your data is encrypted. There used to be, like, Jack can used to just go to any public area where there was Wi-Fi, open up Wireshark, and see what everybody else was communicating on that network, even your passwords, even your credit card numbers. Jack can usually just go to like Starbucks, open up his computer, and start intercepting traffic. But with HTTPS now, you can't do that anymore. Because the data is encrypted. Even if someone like Jack try to intercept it, they don't know what's going on. So yeah, this is symmetric and asymmetric key pairs. I hope you guys enjoy the video. I'll see you guys next time.